Okay, this is my second attempt at standard 2.1, which asks, find the probabilities of the measurement shown below in figure 2.14, which is this figure right here. It says Stern-Gerlach analyzer. It says that the first Stern-Gerlach analyzer is aligned along the n-hat direction defined by angles theta equals pi over 4 and phi equals 5 pi over 3. So that's this first one right here. So from the figure we can see that the first Stern-Gerlach analyzer prepares the state in the positive direction. So our input state is going to be this right here. Using the theta and phi values they give us, we can plug in. We get this right here. And if it's hard to see, this is e to the I 5 pi over 3. Plugging in on Wolfram alpha, we can get a simplified version of cosine of pi over 8 and sine pi over 8. I wanted to keep it in terms of real numbers to start off with before I got into the decimals. So this is our input state right here. So just a side note before we go on to the next step, the positive y-hat direction and the negative y directions, their states can be written in this form right here, with matrices where that's 1 and that's an I, that's 1, that's negative I. The reason it's important to know this is when we go to do the probability of measuring the positive and negative states coming out of the second Stern-Gerlach analyzer, we have to use this formula right here. So it's important to note that these are a little bit different. This ket is a little bit different than this ket. So in order to transfer it to this one, take the adjunct, which essentially turns the column vector into a row vector, and we flip the sign. So we plug this in, and it's pretty simple to analyze, and we get a decimal of around 0.18. So the probability of measuring in the positive y direction is going to be 0.18. Then we essentially do the same steps for the negative y direction. Again, the positive adjunct is sign flipped, so we have an I here instead of negative I. And when we analyze this, we get probability of around 0.53. And that is it for standard, for problem 2.8.